Okay. Thank you all for attending this webinar. Today we'll be talking about Edgenative and why it matters, defining a little bit Edgenative. The definitions today are still very vague or for some, unfortunately, dependent on definition of cloud native. My name is Sami Fodil. I'm the founder and CEO of Taubyte, and I'll be talking through this today. So let's start with some overview of the edge. So what is the edge? What is edge computing? So besides the cloud that everybody is used to, where data goes to and is processed and leverages some technologies that has been around for a long time, like containers and virtualization and so on and so forth, there is a vast infrastructure that is also capable of computing and storage. And that infrastructure is all over the place, from the devices you use every day or you rely on every day, like IoTs and other devices like your mobile phone, your computer, and then going all the way through the infrastructure up to Exchange Edge, which and core network edge, and so on and so forth. For some people, like they depict it as the edge being the top of the pyramid or the center of a circle. I don't like to depict it that way because it's not true. Devices don't need to go to the cloud to communicate. Fortunately, today a lot of our technology is built that way because it's cloud native. This meeting or webinar is a good example. My video from like my webcam, but also the screen sharing, is going all the way to somewhere in the cloud at Google's, and then being encoded alongside the streams from everybody, and then it's shared again. So it's a hub and spoke architecture. And this is why a lot of people depict the edge as either being underneath the cloud or an extension of the cloud, or kind of like the cloud being the center. But it is not true. Cars can communicate between themselves peer-to-peer without needing the cloud. That's called edge-to-edge. And other devices can do the same in a peer-to-peer manner. And that's what should be really happening at the edge, actually. So edge computing as a paradigm leverages all that spectrum of infrastructure from devices to Exchange Edge. And the goal of edge computing is to deliver on things that the cloud cannot deliver on. And hopefully, that's what I hope, and it's what I believe in. The edge will replace most of the cloud use cases today. So the goal of the edge is to guarantee response time, ensure continuation of service, reduce cost of sending data to the cloud. It's very, very expensive. Protect privacy and reduce attack surface. So for privacy, the moment your data goes to the cloud, it's not private anymore. And for attack surface, the cloud is a central place where when it's compromised, everything else is compromised. All right, let's move into the market. So the edge computing market is a new market, though I don't fully believe that, because CDS has been around before the cloud existed. But accounting for the real edge computing market, where computing happens, not just delivering static content, this is a new market. And estimation from the IDC expect the market to grow to 250 billion by 2024. Today, we have around 27 billion actively connected IoT devices worldwide, and we have over 100,000 edge data centers around the world. This is going to grow to more than that, and at some point, the edge will dwarf the cloud, and the cloud would be only that place where data lakes are happening, where processing big data or archiving data will happen. So what are some of the attributes of the cloud or cloud native applications today? So the first thing that the cloud guarantees is connectivity. So when you're building services in the cloud, you expect them to communicate between each other without interruption. So an example is, for example, you're processing a payment. So you're hitting an API, you're hitting a server that could be a VM or whatever, and then or a container, and then that the connectivity with that service is guaranteed, and then that service will reply with a response. And this is a big assumption, and that is core to the cloud, and especially when you go into meshed topologies in the cloud, like microservices, you need to make sure that the connectivity is there all the time. The cloud has this principle of immutable infrastructure. So the cloud allows vertical scaling, but does not allow horizontal scaling. So on the horizontal level, it is immutable. It doesn't change. It is centralized. So that makes the logic behind it pretty simple, right? So you reach out to a server, the server gives you an answer. You write data to a server, and that server manages the coherency of the data, so on and so forth. So it makes it very, very simple. And then the the hardware is homogeneous. So it's either all Intel or all ARM. They all look the same. You don't have to deal with a lot of different CPUs, for example. One big attribute of the cloud is the declarative approach that the cloud has. So in the cloud, everything is addressed in a declarative way. So for example, if you need to access a resource, you need to know a couple things. So the protocol, the IP address or the FQD, and the port, and then path to that resource. And all of those things are static, known ahead of time, and are very dependent on the location. So if that server with that IP address is not available, that resource is not available anymore. If that service moved from one port to the other, that is not available anymore. And that's a big problem when you move to the edge. In the cloud, it's pretty fine. When you move to the edge, and that's an example of a car moving from one 5G cell tower to the other, and using, let's say, a message broker to communicate with nearby cars. That message broker is addressed using an IP address and a port, so it's pretty well declarative. How would you guarantee that that service has always the same IP address and the same port as the car is moving? That's pretty difficult, and this is why the declarative cloud native approach will break at the edge. So now, if we think about Edgenative, I think it's pretty clear that Edgenative is not cloud native, and it has nothing to do with cloud native, which is the truth. Edgenative software has to deal with different things because the cloud is a different universe, it's a different paradigm. So in the edge, we have intermittent connectivity. So we do not have that luxury of always having connectivity. So that example of that car moving from one cell tower to the other, that car can disconnect at any time, but is very likely to go through a disconnection between one cell tower to the other. And an edge native software running both on the car and in those cell towers needs to account for that. We also have the problem of physical insecurity. So your software in the cloud is secure behind thick walls and heavy security, physical security, where in the edge, it's not the case. We have container-based data centers that are pretty easy to break into. You can easily hack into your car and modify the software there, or into a cell tower, and so on and so forth. The other thing is a dynamic infrastructure. So the edge is not something that you can think of ahead of time. Let's just think about the example of the car. Let's say a car manufacturer releases or plan to release a 5G enabled autonomous vehicle, and that vehicle needs to be able to work in the US. So and relies on a service that needs to be available on 5G cell towers or base stations. So how would they do that? Like the declarative cloud native approach says, you need to know all the places or cell towers that you need to deploy code into, and then deploy that code at once all over the place. So that's the declarative way. And you need to keep same IP addresses, you need to keep same ports across all that infrastructure. So the car will be able to always find that service. Not to say in 5G, you need to provision other things like a 5G partition to guarantee low latency and so on and so forth. So in that case, it will be very expensive for that car manufacturer to make that happen. And this is why the declarative way of the cloud doesn't work at the edge. And then the edge is globally distributed. So again, it's not just the US, it's not just one city, it's the whole world. How can you make that car work everywhere? The edge has to, an Edgenative software has to run on diverse hardware, sometimes constrained hardware. So it cannot be, you cannot use VMs, you cannot use containers, because those are hardware dependent. Compiling software for different architectures, or building like, oh, this is a container for ARM, this is a container for Intel, and this is a container for something else, is not very scalable. And then at the edge, it's not just IP. We have other protocols that mainly are related to IoT, but those are still other protocols that Edgenative software needs to be aware of. So, and that's kind of like my kind of conclusion here, and it's really start to put in a real definition for Edgenative. So I believe that Edgenative should have 5 attributes: location and dependent addressing. So instead of having that addressing that's an IP address, port, and then path to a file or path to a REST API or whatever, the addresses should be independent of all of that. They should depend on an ID. And then a protocol should be used with that. So we can say protocol X /ID. That address is independent from the location of that peer service or data, but should be we should be able to derive from it a location dependent address. So, and that would happen like, let's say that car needs a specific service, and let's say that service processes telemetry. So the car will ask for that service using an ID or the location independent address, and the cell tower, which will run that service, will reply and say like, hey, I do have this service, and this is how you can address it. This is the IP address and the port, for example, if the communication is IP. And then the car can use that to communicate with that service. As it moves to the next cell tower, it will be another IP address and port, and that's fine. because each time the car will ask to resolve that location-independent address into a location-dependent address. The second attribute should be resource discovery. So to do that resolution, we need to discover resources and announce resources in a peer-to-peer manner, and have the ability to discover all of that in a automated way. So we should have some kind of a distributed directory that the Edgenative software can tap into. A good example of that is a DHT, or a distributed hash table, that is used by a lot of peer-to-peer networks. So that includes Tailbyte, but also Ethereum V2, BitTorrent, IPFS, and other peer-to-peer systems, and all of that will allow discovering peers, data, and services dynamically. So as that car moves, as you add more cell towers, as the infrastructure itself at the edge changes, those peers are announcing what they can provide. And that's not totally new, right? If you think about the internet, at the beginning of the internet, a lot of the routing was static. So you had to have people writing declaratively IP addresses that are reachable. So each router will have the addresses that it can route to, so on and so forth. At some point, the internet was growing so fast that wasn't feasible anymore. So a protocol called BGP was created. So in BGP, routers are independent, and they announce the routes they have access to other routers. And each router uses that to build a table comparable to a DHT. And it is a distributed table, but it's not a table of hashes, but it is still a distributed directory. And this is how the internet works today on the network routing level. But it doesn't work like that when it comes to software and accessing resources. And this is where we need to get it for the edge. And then portability. So for the edge, we really need software to be compiled into one file, a file that is hardware independent. We cannot afford to have something that needs to be compiled for multiple hardware, or something heavy like a VM or a container that like a container requires many layers to be provisioned, and it takes few minutes. By that time, that car moving from a cell tower to the other would have moved to the next tower. So something like a container wouldn't be portable for the edge. It would be portable for the cloud, but not that much for the edge. And then the fourth attribute is distributed. So Aginative application needs to be distributed. So they need to adopt an approach of provider-consumer instead of client-server. So Edgenative software could provide a service or consume other services, and those services will be discovered and announced instead of being declaratively fixed, or rely on a declaratively fixed service router like in microservices, which is not very good for the edge, because that service router might be unreachable, for example, and then it will break everything down. And then you should also rely on distributed services. So shouldn't rely on something like for storage on something like an S3. S3 is not distributed, or rely on like a centralized database that's not distributed. You should rely on services that are either distributed or local, if that's possible. And then never use static resources. So all the resources should be dynamic, or should be able to be provisioned dynamically for the need of that Aginative software. And then the last attribute is CRDT. So CRDT is something that's gaining a lot of momentum at the edge, and there is a good reason for that. So the reason we need to have a master-slave database architectures is because the data is not in a conflict-free replicated data type way. So we need to have a central point or a central server that makes sure that everything is consistent. Otherwise, they'll break. And we'll find ourselves in an inconsistent state. So at the edge, we can at any time be disconnected from that central place and start this, but keep storing, keep generating and processing data. And we need to when we're connected, we need to communicate that data. If we use a centralized approach, that will be hard to do so. But if we use CRDTs and data is written in a conflict-free data type, conflict-free replicated data type way, when we reconnect with the rest of the network, we can merge the data without conflict, and that's kind of like what would permit data to survive these disconnections. Now, on the other side, we still need to have the application able to work offline and have the being resilient as well. So, for example, if a service that the application needs to is available in a peer and that peer goes down, the software or the Edgenative software should be able to find another peer that provides that service and keep working that way. So yeah, that's basically what Edgenative should be. So location independent addressing, resource discovery, portability, distributed, and CRDT, and that's basically it. And then at Top White, we're really building a platform to help developer build those applications, and we're open for questions. If you have questions, comment, don't agree with any of those attributes, I'm all ears. Okay, let's give it. Okay, David. Let's see. Yeah, I think you can just unmute yourself and ask your question.
All right, great. Yeah, enjoying learning about some of this new stuff. So, and I'm curious about how the native edge setup and scenario, how that differs, hardware wise. And I know we talk about edge hardware and, we talk about gateways, and then there's also something that's becoming a part of the big, just comparatively to 5G and Open RAN. I know there's scenarios where actual really robust servers have to reside on the edge for Open RAN for 5G, but a lot of the other edge type things we do will be just smaller gateways. But I'm curious how the hardware that's going to interact via software with these edge applications, how that's going to look and how it's maybe different for the native edge native.
Yeah, that's a good question. So, what I believe for Edgenative, I really believe Edgenative should be hardware independent, and there will be another component, which is the orchestrator, that would determine if that piece of software, the Edgenative software, I mean, in my mind, it should be a function, a serverless function, but could be something else. It doesn't have to be that. But the orchestrator will determine if that software can be provisioned on the hardware or no. So maybe it would say like, hey, cannot be on this server. It needs to be on something else, and then the IoT gateway will provision that. Could also be something like to provision that software, you need a 5G partition to happen, or you need a GPU. So I think the edge is exactly what you said. It is a spectrum of different hardware. It's a hardware diversity. It's not just one fits all like the cloud. And the orchestrator component, that is not part of the Edgenative principle. but the orchestrator component should be able to move the edge software where it needs to be on the right hardware. And this is why the software should be hardware independent and address resources independently on location and so on and so forth. Like those 5 attributes needs to be there so the orchestration engine can move it where it needs to be, depending on network, hardware, and other parameters.
Okay, great. Yeah, I appreciate that.
Okay, so do we have other questions? If we do not have questions, we could certainly wrap it up.